Hi everyone, welcome to the Open Digital pop-up meetup session. This actually came out of the previous session and is considered like a 1.5 sequel session that came out of the conversation that took place in the chat window, and we saw a need for to show off a CI/CD demo, and we have Mac and Andrie on hand to kind of guide us through typical CI/CD demo or CI/CD workflow presentation. And we'll just cover that right now. Just give me a second. So tonight we're just going to do some, we're going to start off with the CI/CD workflow demo with Mac and Andrie. And directly afterwards, we're going to do a Q&A session. We're going to try and keep the demo going as smoothly as possible. So if you have a question, either raise your hand using the buttons below on Zoom, or please wait until the end of the session if you're able, and then Mac and Andrie can take your questions as we go along. We're going to leave the session open until 6 o'clock, depending on the questions and the content that everyone wants to see. And just a reminder that immediately after this, the Elastic SA Meetup is happening tonight. It's their first digital one. So if you've got an interest in Elastic, you can jump on over there. Thanks a lot. Over to you, Mac and Andrie.
Cool. Thank you very much. I'm just getting to here so I can fully present on my side. Actually, no, really, probably doesn't matter to do it that way. Let's just do it this way. Okay. Share screen. Yes. Desktop 2. Can I have a show of hands as to who was here for our previous chat?
By that you can.
We could do
have a look in the middle.
Yeah. You click on participants. You can click blue raise hands, and everyone can see it.
Yeah, that work looking great. Cool. So we've also got some guys who weren't at the last one, which is lucky as well. Thank you. And someone's pinging me on chat. Welcome everyone. Thank you. Cool. So my goal is to kind of do the demo as lightly as possible. There's 2 of them actually, but for us to be able to have lots of chats and discussions, kind of like it's a meetup, not just a presentation of something. So if that's cool with anyone, yeah, stick up your hand, join in, comment. If we talk CI/CD, we generally also talk about DevOps. They kind of, the bits and pieces connect with those 2. If we talk about that as well, obviously it helps to know what CI/CD is. There we go. Cool. So if I can ask again for another show of hands quickly, CI/CD, who's already using sort of that methodology, who's somewhat, it doesn't mean you're deploying everything in production from the stuff. And then I'm keen to hear from you guys as to what your tooling stack is. So feel free to jump in with a voice comment as to what you guys are using. Artie, Daniel, Lloyd, Mornay, what are you guys using?
Currently using just Jenkins at the moment. So pretty basic, but we're moving towards using Docker and Kubernetes in the near future.
Yeah, we're still very much Microsoft based, so we're on TFS, building packages to Klondike. From Klondike, we ship with Octopus Deploy.
Cool, cool.
We use Jenkins. That's it.
Cool. Are you deploying, can I ask a question? Like in terms of Jenkins stuff, are you deploying to VMs? Are you deploying containerized workloads? What's
Yeah,
the...
Jenkins kind of instruments salt, which sends to LXD containers.
Lekker, very nice.
In our case, it's just using Jenkins to deploy to VMs. So once we have a prepared artifact, we promote it to production via Jenkins to do the whole production on our application stack.
Awesome.
So this is Ryan here. We use Jenkins quite extensively, and also some of the IBM toolkits like BigFix and so on, but mostly deploying VMs and altbars, and then also playing around with Docker and code-ready containers, which is quite exciting.
Cool.
Cool, bananas. Thanks. And I see, yeah, OKD, Bamboo, Artifactory, Travis CI mentioned as well. I think tonight's stuff is probably going to be Jenkins related. Jenkins on one hand is a sort of the boring tool. The other hand is the Swiss Army knife. So it might be a bit heavy for some things, but it pretty much, by all its plugins and things, can do everything it needs to. Sorry, I'm getting confused as to which camera I need to look at. So cool. So CI in this sense is for continuous integration, which relates to having your application code continuously having its builds being done for basic testing, integration testing, and the CD for continuous delivery, which relates to delivering your built application onwards or a part of the release process. So for some people that's continually deploying it for user acceptance testing, but part of the whole mindset around that is fast, small releases rather than your sort of more traditional 3-monthly or 2-weekly release cycles. And again, it's more or less a continuum. Small projects can probably do this very fast, but big projects with lots of external dependencies or interrelated dependencies might not be able to do it to the same degree. This qualified for this is all my opinion, so please feel free to correct me where I'm wrong or we had interesting experiences in trying it. Daniel, did you still want to say something? Daniel, excuse. Okay, so lower that hand there. Cool. So to skip along back to the next slide, for me, can you guys see my screen? I have shown it. I'm not trying to do a full presentation. It's just easier to show the slide that way. If everyone's okay with that? Cool. Yeah, so I'm fairly sure, given this, that we're all related, understand that version control is the starting point for pretty much all of this application code, because it'd be kind of difficult to have other kind of events and things like that as the trigger of when something has changed and a build needs to take place. We found a really cool, while we were prepping for this, we found a really cool kind of couple of definitions around what CI/CD is and the life cycle of that, which are why you see the image credit for Samar Patuli or dzone. So I'm sure you guys are familiar with the dzone website. It's got a lot of cool resources. It's kind of funny sitting prepping this thing, and maybe you guys have been on a similar journey with your own sort of CI pieces, in that it's a lot of work up front, and then you kind of got it done, and you go like, oh, okay, all right, now it's there. So I don't know if anyone else kind of feels the same way around it, but it's like, it looks like this big daunting process, and then you put it all together and it kind of just does what it's supposed to do, in that, like, oh, okay, it's automated. I don't have to do anything more about this. It just goes off and does its thing. I think to the point of where sometimes you come back to a pipeline a few months later and you've forgotten completely what it does, because someone's asked you to change something, and you got to go refigure it is what it was that you actually did in the beginning, to redo it. Alrighty. The demo kind of, to kind of get to it, we can crack on. Andrie, do you want to jump in and say a few words on the next couple of slides before we do that?
For sure. Yeah, for sure. I think just you know, obviously there's some guys that have had some experience or extensive experience deploying software or releasing software with Jenkins and various tools, you know, automation processes or whatever. But I think just for the sanity of everyone else, Mac, just please do me a favor, just click present there. It's slightly so small on my screen. So, you know, just in terms of the general flow of where you would have, as part of CI, having developers work on a code repository, you know, committing things into maybe feature branches or a branch that a developer is working on a certain component or a certain piece of code, and then obviously merging those back in. Now, throughout that, you might have some kind of like sanity checks or steps where, you know, once a developer commits some code, you know, it could trigger off a test or a build or something before it merges into, say, for instance, a dev branch or a QA branch. And then just, you know, tests in between, you know, whether it be kind of unit tests for, you know, like kind of like if you do test-driven development, or if you have developed some tests while developing the application, having those on the components. And then also further than that, doing integration tests where you would say, for instance, you know, I would, you know, deploy a container or whatever with my application, and then maybe spin up a container with a database and seed that database, or do a database migration and inject some data in there, and then see, you know, run some tests against that, to the point where you've done this, you've maybe done some, you know, code analysis to look at the quality of the code or vulnerabilities or whatever, and then to the point where you've got an artifact that's able to be released into production. So yeah, I think you know, in terms of those stages, you would obviously have the stage where you have the source, the building of the application, testing, and then obviously deployment of the artifact into whatever environment. So yeah, I mean, I think in terms of, you know, like, you know, the benefits is like, you know, once you have a proper pipeline set up, you know, developers can focus on, you know, kind of releasing code very quickly, failing fast, and then recovering fast, you know, rather than having to sit through a process where you develop some code, hand it over to QA and testing, whatever, and before it gets to an infra team that needs to spin up some VMs, before you actually find out, hey, I've got a problem here, you know, this thing doesn't really run live. So it really saves a lot of time in that sense, but also the feedback loop in terms of, you know, what's going on, the communication and things like that. Yeah, can you skip on for us, Mr. Mac? Right. So basically, we've gone through kind of an example of, you know, the one back, please. So for instance, you know, you'll have the build running, it's installing some dependencies, test through to that, and then potentially deploy to Kubernetes, or maybe spin up a Docker container or whatever. So yeah, that's about it. Now, Mr. Mac, if you can just skip on there, that's fine. Just one, yeah. Anyway, I think just generally from version control, the continuous integration, again, it's like building and validating and things, and then deploying, and then obviously continuous deployment would then be the release to production. I think in terms of just the flow or the pipeline flow, we've kind of gotten a good idea of what's happening there. So maybe we can jump into a little bit of a demo. It's quite basic. It's on Jenkins. It's quite basic. And then Mac, you can take us over onto OpenShift. Right. I'm going to share my screen here. So guys,
while you follow that, Andrie, I will keep track of the chats with Charles, and give you a heads up if there's anything there.
Yeah, no problem, no problem. So I would recommend anyone that's got a question, or if you want to say, hey, skip on from here, feel free to pop in and, you know, just give your comments or ask questions. Right. Cool. Everyone can see a terminal and a DigitalOcean there. So I would create a droplet, which I've done. One that's already got Docker on it. Yeah, the Docker one, here you can see I'm logged into it. Docker PS. I have a container running. That's Docker in Docker, basically. That one there is Jenkins. So basically what the Docker in Docker does is it's got a daemon exposed. You can see there the Docker daemon is exposed so that the client running on Jenkins can actually speak to that. Now, also what it does is once you you know, do some tests and it needs to spin up a container, it'll actually create a Docker container inside of this container, and then you can run tests against it. So I have here, I've got a basic React application that I have that I've created there. So I'll go over to here. I'll create a new pipeline, and then put in InnoD. I'll create the pipeline. Cool. That one's indexing. So just for interest's sake, what I can do, if anyone's wanting to know, just so that I can explain what's going on here. So basically, this Docker instances that I've got running here, the one which is the Jenkins Docker, which is the Jenkins, you can see there it's running that container, the Docker in Docker. I've got a local volume that's mounted. Yeah, so any code that I commit or any changes that I made there would be kind of persistent almost if I end up killing the container and spinning it up again. Same thing here for Jenkins itself. So it's exposing their port 8080. So you can see that's the public IP and 80. Yeah, that's that. Cool. So I've got this one here. I've created this pipeline. So basically it's just a basic hello world one. So I'll go back to my terminal here. Sorry, I'm using Nano because it's quick and easy. All the Linux guys are going to scream at me now. Home for the win. Right. Going to stage dot, just commit it. Git branch. So it's only got the master, so let's do a development branch. Look, and also production. Right. Cool.
So basically, Andrew, at this point, you're setting up your code repo to handle the pipelines for the different branches that you're going to run.
Yep, that's it. So I created that. I'm just going to scan again to make sure that I can see all the branches in there. Actually, that code that I added there and committed, I shouldn't have done that. That was an initialization one, but we can see it's basically running an NPM. It's currently doing it on the dev branch. Takes a little while, pulls down some, and then it'll just basically run a test as well. While I do that, I'm just going to add some more steps to my Jenkins file.
Any thoughts or questions or queries so far at this point? What you guys are seeing? Any bits and bobs?
Can I ask something that's kind of like that you might still get to?
Yeah.
Yeah, what I wanted to know is like, what are the different strategies that you can use to kind of pin a specific commit to like a Docker image? So I know some people will tag a specific commit on a specific branch with a tag that's used for the version of a Docker image to do that. But are there any other strategies that you guys found that could be useful?
Just to double check, understood. It's the you're talking about how to get a specific point in time referenced to the Docker image you want to build. That's the key output, or maybe it wasn't a Docker image, it was a jar artifact. But either way, pointing, coming back to that git commit kind of from a clear list.
Yeah, something like that. So like, for example, let's say you were to by accident delete that Docker image. How would you get back to the point in time in the code that was used to build it, something like that? And like, what can you use to make doing that easier?
Any suggestions from anyone else here?
Ansible.
George?
Ansible. So do your base image build. So even your the VM running your OS and inside a Docker and everything, up to the point where you actually do your code deployment. So you split it at the code deployment, use Jenkins and everything and CI/CD, where you can deploy into a container, be it a Docker container, a Kubernetes container, use the CI/CD side more. But to get up to that point, because also part of that CI/CD is your test cycle. So you could use something like Eggplant, where you deploy your code and then run your tests initially. But what you might want to do is every now and then actually tear down your base Docker image. So you go back to vanilla. So you can deploy vanilla, a new infrastructure, deploy the Docker, and then the code. So that you know that if the code deployed that you deploy upwards don't work, you can actually go down to the base, redeploy it, and then add your code. Because sometimes you keep on doing code, and something goes wrong. You're not sure, is it now the code or is it something from a previous build? So what you do, you take everything down, rebuild it with Ansible scripts, and then you do a complete code deployment with everything inside it. You can do, if you skipped all of that, you can basically do from a 0 VM with an OS in, with a Kubernetes, build your cluster up, do entire code, entire test cycle all the way, and tear it down in 45 minutes. It doesn't matter if there's a 2-node cluster or 20-node cluster because you parallelize everything. And that gives you the capability also, if you then go into testing, be it internal testing or UAT testing that's external, at any time you can do a complete teardown and a rebuild, run your test, and you know exactly what you're going to have should you do that into the production. So it's just marrying the infrastructure component that fits very nicely in with Ansible, and then the code deployment, the application deployment that fits better in your Jenkins type of world, if that helps.
Yeah, thanks. That certainly, like, I hadn't thought of like the underlying infrastructure stuff around getting that to a particular state. So thank you. Around the Git tags, I think Git tags is useful. I've kind of always seen it and stuff, but you've always got to watch out that you got to make your Git tags as well, that people can't delete them. Otherwise you lose them that way, because the tag is essentially just another pointer to a commit. So it's just maybe a slightly more human friendly version of seeing what a commit instead of a commit SHA. But the point of what if the Docker image gets deleted and you want to rebuild that particular one again, certainly the idea of using a Git tag that will match to the Docker tag is quite a useful one. Anyone else had any other thoughts on how they handle that?
Can I ask? You say the Docker image gets destroyed. So we're saying we're gonna normally what you do, you build the Docker image, but the entire Docker image is a YAML file that says, pull this base image from your outside repository, apply the following code to it, and then push it out. So that entire, even the Docker image that you pull in, that should be, how can I say, it should sit in your repository, it should be tagged not to be deleted, it should have a something like sysdig stamp on it that no one can change it, and if it's changed, your fingerprint show number of it will show it. But you pull that image, add your code from a copy external to internal, and deploy the image. So even your Docker image that you're going to deploy with a code in, that should be part of the entire YAML build process.
Right.
Okay, Andrie, cool. Thanks, George. There's quite a bit, quite a meaty answer. Again, guys, probably as they're hearing that, are probably gonna think like, we're over here on this thing, and that's over there. The more effort you put in, kind of, the less effort is required afterwards. So the more effort, the more you can automate those things, the more they can run unattended and without, and the more you can get that reliability and the repeatability. But it doesn't mean that you have to have it everything all at once. Yeah, so it's great to see like a far in mature kind of idea, as well as kind of things further on. I think one of the things that's nice about what Andrie's showing here is this is very doable for a developer himself, or someone who's doing something and wants to do some CI/CD, but doesn't want to have to necessarily run a full-blown Kubernetes cluster and stuff like that to get the things done. So this piece gives you kind of a good bite-sized chunk of it in terms of how can I do this? How can I make use of, something that looks very similar to the kind of workflow that you might have in a big environment with build servers and stuff like that, following the same kind of processes, but on a smaller scale as well. So Andrie, you want to carry on?
Yeah, for sure. Cool. So basically, I did a test coverage there for the code. So that is on the master branch. So I'm just going to edit my Jenkins file here again. Sorry. Oop. Right. So you can see in here, the pipeline kicks off a Docker container, yeah, and then it runs npm install, and it's got a test script that it runs through. That's the pipeline here. So it does a build, npm install, all the modules, and then the test. So
Andrie, if I can,
yeah.
our previous gentleman had asked about the Docker. Just go back to your left, your nano skip the previous one. We had Docker and the test npm install.
Okay, so here on top, can you see this?
Did you just scroll up? Okay. So that's actually where you pull the initial Docker image with your runtime and everything out of your repository. So the only way with that, where he said his Docker image got the storage, would actually be if it got deleted out of his repository. Most of the time, that will be pulled from an external repository into an on-site internal repository that's security protected, where you pull something in, use something like Sysdig to actually scan it, make sure it is a valid one, where you can actually check the ancestry of it. And once it's in there, you actually lock it so no one can delete it. So now what you do is every time you build, you use that base image. So the chance of actually losing the original Docker image should be just about zero, because you can lock it so no one can delete it and no one can change it. And also because of this issue Docker registry, you can back it up on a regular basis. So even if last night's registry got deleted because someone deleted the persistent volume, you should be able to go back to the previous night where the repository, your registry was set, where this Docker image is still there. Okay, I'm done.
Right, no problem. Okay, cool. So I have gotten to the step, and now I'm just adding stages for delivering to the different environments, development to production.
So I think just the kind of the basic formatting of the stuff is obviously Jenkins shows the pipeline running with its pretty colors on the right, but it comes back to this text over here, which is also sitting in Git and is version controlled. So as Andrie adds stages, they just nicely formatted little blocks of text to update the Jenkins pipelines.
And you can tag this pipeline with the code so that the code versioning and which pipeline was active at that stage, they are all actually tied together.
Yep.
Right, cool. So let me go back to my branches. I'm going to run this again. Sorry, this takes a little bit of time. I think in between, so basically I'll go back into this again. Oops. So from here, you'll see that there are these test phases, and then with the delivery, it's got a prompt here that'll give me an input message that says, you know, once this deployment is run, it should expose the application for me to hit it through a web browser. Once I've tested it, I'll have to manually say, okay, proceed, I could reach it. Then it'll run a script to actually kill the container, the test container, and then, you know, have the opportunity to deploy to production, which makes it kind of neat where, you know, in certain environments, for you to be able to just run tests, having to request infrastructure or VMs or things like that, you know, at the end of it, you'll end up having, you know, what they used to call VM sprawl. So in this instance, you can basically on request fire up an environment to run your tests against, and then, you know, break it down again. So which makes it quite nice. I think, Mac, you can give us some stats, but we had something that, you know, guys took a reasonable amount of time, like 2-3 days to set up the environment.
It was 3 weeks.
Yeah, 3 weeks. And we were able to kind of like do that entire environment in under half an hour.
Yeah.
Yeah.
And this is also what they refer to as software-defined infrastructure.
Yeah. So infrastructure as code. So I mean, a colleague of mine, he's quite the Terraform expert. He, you know, was in the environment where there was a massive cloud deployment out with databases and all components and things, and it would basically take the guys a month to have to manually deploy all of these components. It took him about 3 months to do so, but he created Terraform where he could, in under an hour, deploy a new multi-tenanted environment. And I mean, like, it was serious stuff. So, and, you know, obviously if you put that initial effort in to document things and get it into code and like automation, it definitely pays off. Right. So basically,
Andrew.
Shout out to my buddy Corneille. Let me just say git branch. So I made these changes on the master branch. So obviously I'm going to have to go and just get it over to the other branches as well. Git. Master. Check out.
I think one of the things that comes through as well in this stuff is that for these kind of things, tests are kind of critical. Not just so that you can have a pretty dot in your in your pipeline, but so that you can have some confidence in what you're going to deploy, because otherwise you're basically you're making putting in great plumbing for a sewerage system that you can deliver rubbish really fast.
Yeah.
And that's only one. So getting the speed up is only one part of the CI process. You want speed as well as reliability. So the speed is including getting that testing in place as well. And as you can see from with Jenkins, I mean, a lot of these things can be scripts, so you can reuse pieces that you were already doing elsewhere, as you start to onboard things into your CI process, you don't necessarily have to suddenly rip and replace everything out. Jenkins can do a lot of stuff with its DSL, but you can also shell out to quite useful pieces, as depending on your familiarity. Andrie, over to you.
All right. So sorry, I really like to get through this so that you can show some of that OpenShift goodness. Yeah. So basically, I ran the master branch again, which only does build and test. We go through there. Let's run the development branch. Luckily, I should be caching those builds, so I don't have to go through that long process again. But let's take development. All right. So very much of the same. It should be going through. Cool. So yeah, so basically it's going through that stage. It's going to fire up. You can have a look here. Jenkins. It's got another Jenkins file in here. Cat Jenkins file. Right. So again, it's using Node. This is what it's going to do inside of that Docker for Docker. So basically, it's going to deploy, run the tests against it, and then serve up. There's a script here for development called deliver for deployment. So if we go to scripts, nice deliver for deployments. Cool. So basically, it is going to run an npm start. So that npm start is going to serve up the Node.js app on port 3000. Let's see how far we are from there. And then obviously kill it up afterwards. Any questions so far? This should go pretty quick. Right. Cool. So if we see there's that prompt. Go back to my script. There I have port 3000. So let's take this IP address. It's not localhost. It's on the cloud somewhere. Right. And 3000. Cool. There's my React app. Didn't have time to put a proper site up, but you can see it there. And then once I go back to Jenkins, I can proceed. Let me just go this side as well so I can show you guys Docker PS. Like I mentioned before, we've got a Docker and Docker, which means Docker exec-it, sorry, -it, that one, and sh. It doesn't have bash. Funny thing, Docker PS, it's got another one in here. So inside this Docker is a separate Docker running. It's publishing on port 3000. And what I'm going to do now is I'll proceed, and that proceed is going to make it run the kill script. Docker PS. You can see I'm going to go back into this one that I did before. Docker PS again. Poof, it's gone. So yeah, it killed off that container. Right. And then I can go over onto production. And it's going to do very much the same. So it'll go through the process, spin up the container. This time it's going to run a different script, which is going to be the proper production. So it's a node module called serve. You can also do npm install -g serve. That generally puts it out on port 5000, I think. So yeah, that's going to do very much the same. After that, now I can link that step to say, when I'm in development branch and I have tested the application that it's live and I click proceed, instead of it just ending there, it'll actually kick off the production deployment as well. In between that, you can insert code scans, code analysis, reporting, things like that, and obviously build that out to more environments if you wish. Mac, I'm going to actually leave it there. I see we're we're quite short on time. So you feel free to take over from me.
Cool
That
bananas.
was of value. Thanks, guys.
Alrighty. So while stop that one. Share the screen at the top. While Andrie's done there, I'm just sharing my screen off at the top. Just let me know if you can all see that. If anyone can't see it, it looks all right. What I've got here is OpenShift Container Platform 4, but that's really just the way to host a Kubernetes environment. What I've got up on the screen here is some ingresses or routes, just links to what I've got on here on the sides. And obviously, much like Andrie's scenario, we've got a Jenkins over here, and we're going to make use of code to build a JBoss Wildfly application and have it run through some processes. So we can see here that we have run this pipeline. Has gone through it's got several stages. And what I'm going to do after that is I'll just show you what the actual code itself looks like. So I'm going to go ahead. And the reason for bringing up this shell up on the screen here is to make the point of, so you can, while you can kick off pipelines and things like that, manually and things like that, typically you're going to use a webhook or something based on a commit. If you're going to follow all of these sort of Git flow type scenarios, very important to this whole process is cool, we've got automatic builds happening, but therefore you got to make sure that your controls around what code gets merged have to be really, should be good and proper in terms of who may merge, how you handle pull requests or merge requests, and those kind of things. Do you want guys to build stuff, automatically from their branches, but they're not, follow approvals process? So we haven't put any any code-based approval processes in here. I'm saying start this build. Oh, and it says I'm not logged in. Cool, which is all good and well. So I'm just going to double check that I'm logged in here. Yes, because it expired. So what one can do as well within other pipelines and tooling and stuff is also, and we do this at some places, is we embed kubectl or OC into our Jenkins itself, so that we can call it from inside of a Jenkins pipeline. So my point of showing the screen here is when I click start build, we should see the next build automatically kick off in OpenShift. There it goes. So what's happened is my cluster has been told kick off a build. The build kind that it's started, and pull that out of the way, is the build kind of tasks open Jenkins pipeline. It's going to run through several processes. What it does is just to kind of show kind of like the complexity kind of related pieces of it. Let me pull up the actual code itself. It's doing a git checkout. It's a Maven build, so it's pulling all kinds of things out of the Maven mirrors and things like that. And once it's done that, so I'm just going to scroll that. Sorry, that's kind of massive. There we go. Okay, cool. It's going to go check against Nexus. And that all happened really fast. So I'm going to scoot back to the test for a second. And that should be it. Yeah. So it's talking to Nexus at this point, doing or it was, or Sonar Cube in that case, with a Sonar Cube script to do static code analysis. So that's where you have your code quality rules as to little, silly things like don't allow spaces at the end of a line of code, down to kind of more heavy things where you got pattern recognition of just poor code practices. So that's using Sonar Cube here. Sonar Cube is a free and open source application, although it does also have paid for components, much like Nexus has free and or paid for components. So if I go back to our pipeline over here, and I guess get scrolling up and see where we've gotten to there. At this point, we're busy building the container image, and I just want to scoot really fast to Key. Key is a Docker registry you can host yourself. You can have your own container images, free and or paid for, depending on how you want to do it. And because it's an open source project, you can host it yourself, or at least most of it. Of course, there's always just like straight, Docker registry, Python shell kind of thing. What I wanted to show you is that it's empty at the moment. I don't have any images built. The build image is still busy running. So just going to check on this side to show you what it's doing. And this is scooting really fast through this, but my build is busy running. It's probably almost finished. OC logs -f, this thing. So I just want to show the logs scroll through. Yeah, and I can see it's busy pushing the image to the Key registry. My pipeline is run along, and if I go look at Key and do a refresh here, we'll see that I have got a Docker image. I know that was really kind of quick and probably jumpy, but so the point is, we can see here, one of the nice little things about Key, as with other things, and most of them, Harbor and the other ones, they all actually tend to use the same open source project under the hood, something called Claire, which was part of, as with Key, was part of the CoreOS project. And that does vulnerability scanning on your image. So in your dev process, you should do your application level code quality checks and things like that. But you should also be doing post-build security scans. The reason for that is obviously, ideally you don't have really old containers or really old artifacts lying around, but it happens in real life. So there may not have been a vulnerability when the code was originally checked, but a month down the line or 2 months down the line, having a tool that has scanned the things with a database of what it's got inside it will then tell you, oh, actually this new vulnerability affects this new container that or artifact
Mac,
that you've got. So
Mac, just to add there, sorry, Mac. So for instance, when you pull down Docker images from Docker Hub or other providers as well, I mean,
yeah,
even large companies that have .NET containers or things like that, those things tend to sometimes have vulnerabilities as well. I've seen that, especially kind of like just using straight .NET repositories, the public ones. Whereas if you use something like Key, or even Red Hat has got verified images that's been scanned and secured beforehand.
and I think I probably waited too long. Let me just check if that's running through. Oh, somebody approved the promotion. Thank you, OpenTLC manager, whoever approved that. Last time I sat and watched this, and it hadn't actually promoted it. So now if I go back to Key and I refresh this, what I should see is the second part of what this pipeline did, which was quite a useful little way. This kind of relates to somewhat George may have mentioned, what Timo had as well. So you've got a container. Hello, refresh please. You've got some code. How do you promote it through your different environments? So ideally, your container image, well, I mean, not ideally, it's immutable. The container image itself, for its particular SHA sum, that SHA-256 that we can see off on the right here in the tiny font, that is unique. If a byte changes anywhere in this thing, that SHA sum will be different. But how do we then go, okay, how do we move our images along through environments? And one of the things that is quite useful to do, let me just restart this quickly. Hello? Come on.
It's promote to stage, bud.
Yeah, I'm looking for it. Can't find it. It says it did it.
Collapse that. Collapse
Yeah,
that.
I'm just going to reload that page while it does that. So one of the little tricks that you could do And what we do with it, there we go. Sorry, thank you. Okay, it's promoting to stage. There we go. Is this little piece, which is just, it runs a little shell script. So it spawns a Scopeo, and it runs that Scopeo command that you may or may not be able to see really tiny over here, which uses Scopeo. Scopeo is a command line tool for inspecting or copying, for interacting with container images. What's nice is you can inspect and interrogate a image remotely without having to fully download the image yourself. So one of the pains with, especially if you start trying to look at like WebLogic container images and things like that, is they get pretty huge. So if you want to download like 5 different ones, it ends up being a real pain, especially if you just want to know what kind of it contains or what it's made of. Scopeo is kind of useful for that. And it, as well as using for that, you can also use Scopeo to copy container images. So it's, you know, with the more expensive container registries, you can get replication and sync and things like that. You can very much do the same kind of things yourself, literally via a line, in this case, in a Jenkins pipeline that says, once I've pushed something, use Scopeo to copy it somewhere else as well. So that gives you the duplicated container images.
Mac, do you mind just popping over to Sonar Cube quickly?
Sure.
I don't know if it's going to be easy to find, but there would be a view where it'll show you during the build. It'll look out for, you know, kind of code smells and you know, maybe there's modules that are outdated or vulnerable, and it can give you a nice summary of listen, this is your team. This is, for instance, the code base that you have. It'll take 4 members of your team with these skills 3 or 4 days to complete, and these are the kind of pieces of code that you need to look at. So it gives you some very good insights into code quality.
Pull this up here. That's the kind of report that you're getting. That's key, sorry. That's, yes, there we go. I'm looking for the reports. No, that was the, there we go. Sonar Cube, there's a screenshot. So I only got a screenshot for you right now. I haven't run the analysis yet. It hasn't shown up on my code yet, but that's kind of what it would look like, this piece here, below the if key enabled.
Sweet.
Alrighty, so because of our time, I'm not going to go more on that. Let's back it here. So what you can just see from this little piece here is we've just basically added an alias, a second tag onto an existing image, and we've just tagged it as stage. So what happens is every time we run this and we do a build, if we promote it to stage, it overwrites the tag, the Docker tag named stage with what we want to run, so that we end up with our container running. So what that looks like is, go to here, roots. I'm going to find my tasks in stage and my tasks in dev. So there's a pod name. It's nothing to really too much to report, but this is the one that is running from stage. And here is my similar one running for dev. I guess it doesn't tell you a whole lot, but I'm going to try kill instance and let it go through.
You should see it kicking off a new instance again.
There we go.
It's basically just a little Java app that's like a health / load generator.
Yeah. So back to our kind of pipeline. I want to get the actual pipeline code itself quickly, which I've got over here. If you bear with me for 30 seconds.
While you do that, so basically this one is a complete pipeline to deploy, or it's a template for deploying a pipeline that's obviously got a source control management. We use GOGs here, but obviously in the enterprise, you'll probably GitHub, GitLab, Azure DevOps, whatever. And then code analysis, that's Sonar Cube, and then the nexus for your repository, and then you can take your code through that workflow.
Cool. Oh, I overloaded. I thought maybe I'd overloaded my, yeah, probably overloaded my computer a bit.
Mac, I think we've got like 5 minutes for any
Yeah,
other
so-
questions or whatever.
So yeah, let's have some questions while I pop this up on the screen. Whatever, let's just do it here. Cool, so what I've got up on the screen here, this is the pipeline code itself, which is kind of that first section at the top. That is that's wrapper code for Kubernetes to say this is a build definition. Build config, I think in this case is could be specific to OpenShift.
It is.
But below this piece is the actual Jenkins file itself. That's the Jenkins pipeline. And so they make pretty good use of the Jenkins DSL here. So making use of the git branch command, pulling in variables, making use of JUnit testing, very usefully via, obviously there's, like I talk about shelling out, there's several of these steps are shell outs. So they're the same kind of things that someone might want to do in themselves if they run a Maven command to de-skip tests and things like that themselves. So in that sense, like I was talking about earlier, of being able to make use of the stuff that you currently use and start pulling that into an automation process. And then there's also examples of where they use DSL plugins and things like that. That section is for OpenShift. Similarly, there's DSL plugins for Kubernetes as well. Yeah, there's the shell out for Scopeo, and that's the lovely pipeline code. This is all kind of available. You guys can get it. It's not. I didn't write all the stuff myself, so feel free to grab it after the session if you want. But any questions? Any kind of thoughts? Like one of the things I asked earlier on was like, what's your war stories? What's the things of we solved this, or wow, we had some challenges with one other example.
Mac, I see Roger's got a question.
Yeah, Roger.
He mentioned earlier that how do you think Scopio does this remotely? Is it using jar and a directory and a dictionary to do that?
How does it do the inspect remotely? It's, well, when I say it inspect remotely, some of it is local and some of it's not. But what it does, instead of downloading the entire container image, it downloads the metadata for the container and then can selectively pull certain pieces from it. So it runs, the Scopeo command runs locally, connects typically to a remote container registry, although it can also talk to locally cached images if you've got them as well. So it's useful for copying a local cached image up to a container registry, or comparing the difference between what you've got locally and what's on a remote registry. But there's not a lot of tools for, like, you can't normally just browse a container registry and see there's oftentimes not especially in terms of one that you run behind the head, it's very difficult often to just see what's inside of a container. Scopeo makes that.
Sorry, Mike. I think it's happened to me many times where I was like, okay, cool, there's a Docker image on Docker Hub, but like, how on earth is it built? If I have to create my own Docker file, what are the steps? Which kind of is it node this version? Are there install steps in it? How does the copy and the arguments and things work? So, which makes it quite nice, because it's a good place to then start with if you need to do kind of multi-stage Docker build, you can build inside the Docker container and then publish as well.
I think the best thing is always whichever Docker image container you're planning to use, the base on which you will then build, they will always come with a Docker file that shows you how that image is built, which one it starts off with as the base. And if you do your homework, you'll actually go to that one and have a look at each Docker file. So you basically go up the ancestry tree and look at where does this come from? Who built it? Is every layer, because all of this ends up being layers of that Docker image, to make sure that all the layers that you are putting together are all coming from trusted sources. And this is also what a lot of the scanning tools will do. They'll look at the Docker file, they look at the image, they look at a shard number, they compare all of this. Then they go to the next one, they compare it to the next one, to make sure that what you're using is from a trusted source. And that trusted source made sure that all the layers that's in there, and all the layers are pretty much just Docker files, one on top of another on top of another, that you inherit the use as a build.
Any other questions?
Thanks for the awesome demo, guys. It was really cool.
Yeah, thanks for the time. It was interesting.
Thanks, guys.
Right. Thank you
See
so
you next
much
time.
for taking some time and spending it with us. Have fun.